All right, seventh graders. I know Tuesday was supposed to be dress good, feel good day, but I felt so good I decided might as well just keep it going for the week here. So I put on another shirt, tie, and jacket to make the video notes here for you today. So hopefully you guys are feeling good too. We're doing great. Let's dive into the notes here and start talking a little bit about our next unit, which is atoms. Okay, and we're gonna start with atoms, and we're gonna talk about the periodic table, and then we'll get a little bit more into some other pieces of matter. We'll go through a little bit of states of matter and things like that too. So um, let's go ahead and dive into it. I do want to mention, um, not to make you feel bad, but this would have been the week that we would have taken the science air test, right? And so we're not taking it, which is awesome. So that's great. We would have been spending the last 3 weeks still working on moon phase stuff, but it would have taken us a little bit longer to get through that unit because we would have been doing some review, some what I called review and refresh. So it would kind of go back and go back over some of the stuff that would be on your guys' test that we would have taken this week. Now, that's the good news, but usually with good news is that there's bad news. And the bad news is that after we take that test is when we would watch normally Jurassic Park. So since we're not in school, I can't really put Jurassic Park on here. I don't know. Maybe I'll think about it as an extension next week or something like that for if you have an opportunity to be able to watch it somehow, to watch it with some discussion questions that we would have normally done in class. So, all right. So you have a document here for the atoms, for the atom. As the way I'm doing this time is we're going to break this into a couple different documents instead of having to keep coming back. So this is just on the atom, and it's a guided notes doc, so it's a little bit less typing for you. When you come to a blank, just like we've done all year in class, there's either a word or a phrase for you to fill in. It might even be like a whole definition for you to do. So just kind of make sure you're paying attention to what the doc has and what it's missing compared to what my notes are showing. You are required to have that all down. As always, we'll probably have some sort of open note test or assessment or mini quiz or something. And so you want to make sure you have all this information because that's going to help you when it comes to those. All right, so let's go ahead and get to this here. Atoms and the periodic table. Okay, so we have this intro video here to start, and I'm just going to play it in here, and then we'll go from there. And we're going to play it right here in this video, in the PowerPoint. I'll make it full screen as this guy kind of goes through and he talks a little bit about exactly what an atom is.
Let's take a closer look at atoms. Atoms are the building blocks that make up everything, all stuff, everywhere. Here I've got some drawings. This is table salt, a solid. Here's water, a liquid. And finally, oxygen gas. And what we're looking at here is what we'd see if we could take these three things and zoom in zillions and zillions and zillions of times. And if we could look at these closely enough, we'd be able to see the atoms, these little building blocks that make everything up. Now, atoms aren't really little colored circles, but it's a good way to think about them, and it's the way we'll usually draw them when we're learning about this stuff. Atoms are super tiny. They are so tiny, it can be really hard to wrap your head around how tiny they are. Here is something that might help you think about this. Take a piece of paper. Look at how wide it is here. All right? This is so incredibly thin. Now, atoms are so small that it would take 1 million atoms lined up next to each other in a row to be as thick as this tiny width of paper. That's how small atoms are. Now, what I want to do now is look even closer at an atom. Let's take one of these atoms here and zoom in even more so we can see what's inside of it. Here's a magnified view of one atom. It's not a perfect representation of exactly what an atom would look like, but it's close enough for right now. And check this out. The atom itself is made up of even smaller things, right? So that we said atoms are like the building block for all of stuff. But then if you look at an atom, it has even smaller building blocks that make it up. So in the center of the atom is something called the nucleus. And the nucleus is made up of two tiny particles. There are protons, which I've drawn as red circles here, and then there are neutrons, which I've drawn as blue circles. Nucleus is here in the middle of the atom. And then on the outside of the atom, there are these little black circles that I'm using to represent electrons. The electrons, you'll see, are connected to these sort of oval paths, and I've drawn these in to show that the electrons are constantly moving. They're flying around the outside of the atom at an incredibly high speed, whereas the nucleus stays solid here right in the middle of the atom. Now, electric charge is very important when we're talking about atoms for a number of reasons. Protons have a positive charge. A proton has a charge of 1 plus. Electrons, on the other hand, have a negative charge. One electron has a charge of 1 minus. Now, neutrons, they don't have an electric charge at all. They have a charge of 0. And neutral is a word that we use to refer to something that doesn't have a charge. So neutrons sounds a lot like neutral. Now, positive and negative charges attract. Remember that? Opposite charges attract. And that has important consequences for how this atom works. We said that these electrons are flying around the outside of the atom. They're moving really fast. So why don't they just fly out into space? Well, the reason why is because the negatively charged electrons are attracted to the positively charged protons. So the protons kind of pull the electrons in. They keep them from just flying away. But the electrons are moving around so fast that they're not able to actually pull in here and actually touch the protons. So that's why they keep staying on the outside and don't just crash in here and all touch the protons. Now, sometimes people ask, well, neutrons don't have a charge. Why are they important at all? Well, it seems that neutrons help keep all of the particles in the nucleus strongly connected to each other. Now, electrical charge is important. Something else that's important with atoms is what their mass is, how much they weigh. So in order to figure that out, we have to look at the mass of the various things that make up the atom. Now, a proton and a neutron are very, very similar in size and in mass. And they both weigh about this many grams. Look at what a tiny number this is, right? There's a decimal place all the way over here. This is a number that it's best to represent in scientific notation instead. But however you write this, it's a really tiny, unwieldy number. So scientists came up with another way to measure the mass of a proton or neutron, and that's using a unit called the AMU, the atomic mass unit. And they said, okay, one proton or one neutron weighs about 1 AMU. That's a lot easier to use than this measurement here. So proton or neutron weighs about 1 AMU. An electron, on the other hand, is much, much, much smaller than a proton or a neutron. It weighs only 0.000549 AMU. So a tiny fraction of how much a proton or a neutron weighs. For this reason, when we're talking about the mass of atoms, which we'll talk about later on, we usually add up the protons and neutrons to find out how many AMUs the atom weighs. And then we usually don't even worry about the electrons at all because they're so tiny. They don't really have much of an influence on how much an atom weighs. It's like when you get on a scale to weigh yourself, you don't worry about the ring you're wearing or whether you're wearing a necklace or something, because those things are just so tiny, they weigh so little compared to how much you weigh that it doesn't really influence your weight. So protons and neutrons, 1 AMU, and electrons, a tiny fraction of that. Now, I said that the atom, the way it's drawn here, isn't a perfect representation of what atoms would actually look like. We'll talk more about that later, but there are two things that I want to bring up for right now. The first is the electrons and how they move. This drawing might make you think that the electrons are spinning around in nice circles on the outside of the atom. That's actually not what happens. They're buzzing around much more randomly, kind of like hyperactive flies all over the place. We'll talk more about that later. The second thing has to do with the size of the nucleus and how far the electrons are from it. If this were a real atom blown up many, many times, and the nucleus were the size of a grape, the electrons out here would be almost a mile away. Just have this grape-sized nucleus, and a mile away would be the electrons spinning on the outside. So that means that most of an atom is actually empty space. Anyway, now that we've talked about what an atom looks like and the particles that make it up, we can go and discuss some of the characteristics that we can use to describe atoms. These are things like atomic number, mass number, and net charge.
Okay, and we'll get to that here in a bit here as well. All right, so for my purposes more so than your guys' purposes, it's a whole lot easier if I stop this part of the notes right now, and I'm going to come back for video number 2 here using the same doc, going through and doing the notes. It just makes it a lot easier for uploading and all this other stuff. So we'll stop here. Go ahead and click on the other video for class notes part 2 as we go through the atoms.